everyone, my name is Giancarlo Villadorino.
Hi, my name is Gian Paulo Resuena.
My name is Gian Chris Alegre.
Data visualization. Measuring data similarity and dissimilarity. Data visualization. Data visualization is the graphical representation of information and data. By using visual elements like charts, graphs, and maps, data visualization tools provide an accessible way to see and understand trends, outliers, and patterns in data. In the world of big data, data visualization tools and technologies are essential to analyze massive amounts of information and make data-driven decisions. So, data visualization ay yung paggagawa ng representation ng mga nakuhang impormasyon at data sa pamagitan ng iba't ibang visual elements katulad ng charts, graphs, at maps. So, meron ring mga tools na pwedeng magamit para magkaroon ng representation ang mga information na nakuha para mas maintindihan at makita yung possible trends, outliers, at mga patterns sa data. Dahil sobrang dami ng pwedeng makuhang data, ang pag-visualizations ng data ay napakahalaga para mas madaling maintindihan yung mga impormasyon at makagawa ng magandang desisyon para sa isang kumpanya.
Measuring data similarity and dissimilarity. Distance or similarity measure are essential in solving many pattern recognition problems such as classification and clustering. Various distance similarity measures are available in the literature to compare two data distributions. As the name suggests, a similarity measures how close two distributions are. For multivariate data, complex methods are developed to answer these questions. Kapag sinabi natin na similarity and dissimilarity measure, meaning it is about a numerical measure. So, ang similarity measure is a measure of how similar are the two objects or how alike they are. On the other hand, ang dissimilarity naman is kabaliktaran ng similarity, which means that it's measure how different are the two objects. Similarity measure is a numerical measure of how alike two data objects are. So, tulad po ito ng sinabi ko kanina. Next is higher when objects are more alike. So, kapag ang value ay mataas, it means ang two objects ay more alike. Next is often falls in the range of 0 and 1. So, ang value ng similarity measure ay nagre-range sa 0 saka 1. Dissimilarity measure is a numerical measures of how different two data objects are. So it is also a numerical measure of how different the two objects. So, kabaliktaran po siya ng similarity measure. Next is lower when objects are more alike. So, sa kabaliktaran, kapag ang value is lower, the objects are more alike. Next is minimum dissimilarity is often 0, while the upper limit varies depending on how much variation can be. So, minimum dissimilarity is often 0, upper limit may be any number. So, yun po yan. Proximity refers to either a similarity or dissimilarity. So, meaning, proximity measures refer to the measures of similarity and dissimilarity.
Single attribute. Single or dissimilarity measures. In here, P and Q are the attribute values for two data objects. When the attribute type is nominal, its dissimilarity is D equals to 0 if X is equal to Y, and 1 if X is not equal to Y, while in similarity is vice versa to the dissimilarity. In this case, similarity is equals to 1 if X is equals to Y, and similarity is equals to 0 if x is not equal to y. In ordinal, d is equals to x minus y divided by n minus 1. The values are mapped into integers from 0 to n minus 1, where n is equals to the number of values, while in similarity is simple to understand because similarity is equals to 1 minus dissimilarity. Lastly is interval or ratio in dissimilarity. The d is equals to x minus y, while in similarity, it is s is equals to negative dissimilarity, and similarity is equals to 1 divided by 1 plus dissimilarity. S is equals to e raised to the number of negative dissimilarity.
Multiple attributes. Distance between instances with multiple attributes. Ngayon naman ay yung pag-solve ng distance between instance with multiple attributes. So, ang halimbawa ng multiple attributes ay ang contact number. So, possible na magkaroon ng maraming contact number ang isang data object. Kung saan, ang single attributes naman, ang halimbawa nito ay age na isa lang dapat ang value ng age ng isang person as data object. Euclidean distance. Ito naman yung unang halimbawa ng pag-solve ng distance. Ito ay based sa Pythagorean theorem. So, according sa formula para ma-solve ang distance is distance of x, y is equal to square root of summation of k is equal to 1 to n and square root of x sub k minus y sub k, where n is the number of dimensions or attributes and x sub k and y sub k are respectively the kth attributes or components or data objects x and y. Standardization or normalization may be necessary to ensure an attribute does not skew the distance due to different scales. Kaya mahalagang gawing standard yung mga values kung ito ay nasa iba't ibang scale, like the value ay naka-centimeter, millimeter o meter. Kaya dapat natin itong i-convert sa isang single unit para maging balance or not skew the distances. Ito naman yung example na itatry natin na i-solve yung distance ng bawat points using Euclidean distance. So dito meron tayong 4 points at makikita natin yung dito yung x and y coordinates ng bawat points. At ito yung process ng paggamit ng Euclidean formula. Dito, hahanapin natin yung distance ng point 1 to point 2. So, sa una, sinubstitute natin yung bawat value ng point 1 at point 2 sa una is value ng x ng point 1 at minus value ng x ng point 2. At same rin para sa value ng y sa isa't isa. At after nun, may nakuha tayong negative 2 raised to 2 plus 2 raised to 2 at naging ng 4 plus 4 at naging 8. So ngayon, ang square root ng 8 is equal to 2.828. Ngayon, nakuha na natin yung distance between point 1 to point 2. At ito yung kung paano ginagamit ang Euclidean formula. And using the Euclidean distance, malalaman natin kung alin ang dissimilar and similar sa mga points. So ito yung distance matrix na nakuha natin. Ito yung mga distance ng mga points sa bawat isa. Ginagamit natin yung formulang ng Euclidean para makagawa ng ganitong distance matrix. So, mapapansin natin ng point 1 and point 4 ang pinaka-dissimilar dahil sila yung may pinakamalayong distance. At P2 at P3 naman yung may pinaka-similar dahil sila ang pinakamalapit na distance.
So ito po yung Minkowski distance. Siya po ay generalization of Euclidean distance. So ang formula po niya is d of x, y is equal to open parenthesis summation of k equal to 1 to n absolute value of xk minus yk, then power r, then close parenthesis power 1 over r. So nakadepende po itong formula sa value ng r. Kapag yung r is equal to 1, so Manhattan distance. If yung r is equal to 2, Euclidean distance. So if r to infinity, supremum distance. So where r is a parameter n is the number of dimensions, which is attributes, and xk and yk are respectively the kth attributes, which is components or data objects x and y. So ito po yung examples. So if yung R nga is equal to 1, city block, Manhattan, taxi cab, L1 long distance, and meron pa po siyang another example na coming distance, which is just the number of bits that are different between two binary vectors. So kapag naman po yung R is equal to 2, Euclidean distance, L2 norm. Then kapag yung R to infinity, supremum distance. So L maximum norm, saka L infinity norm. Distance. This is the maximum difference between any components of the vectors. This is the distance matrix where L1 is Manhattan and L2 is Euclidean. So we need to solve how we get 4 as the distance of P1 to P2 in Manhattan. We need to subtract the x of P1 and x of P2 depending of the formula, which is equals to negative 2. So the absolute value of negative 2 is positive 2. So if R is equal to 1, then there is no changes, so we get the first value. Next, we need to subtract the y of P1 and y of P2, which is 2 and 0. So it will equal to positive 2. And the absolute value of positive 2 is positive 2 also. And the R is 1, so no changes. Then we need to add the value of x and y. So 2 plus 2 is equals to 4. Then the power to the 1 over 1, which is also 1. So there's no changes to the value. So the distance of P1 and P2 is equal to 4. So in L2, in Euclidean distance, the formula is different. Mr. Giancarlo Adorino explained it earlier.
Next is Manhattan distance. So to solve for the Manhattan distance, let us first look in the table above. In this table, it states in the first column all the points from point 1 to point 4. And in the next column is where we can see the possible values of the x, just like in the last column, which is the y. So the point 1 is equals to 0, which is the value of the x1, by the way, and 2 is for the value of the y1. And in point 2 is equals to 2, which is the value of the x2, and 0 for the value of y2. So to solve for the distance, we can easily formulate x1 minus x2, then add it to the total of y1 minus y2. We need to substitute all the values first to proceed for the next solving process. So in here we can see that the value is already substituted, and we can easily add 2 plus 2 and get the exact answer that we wanted, which is the 4. So we can come to the conclusion that the distance from point 1 to point 2 is 4, and the distance to point 2 to point 1 is also 4. In there we can see the similarity for the points.
Common properties of distance. Distances such as the Euclidean distance have some well-known properties. Ito naman ang common properties ng distance. Meron tayong positivity, symmetry, at triangle inequality. So, positivity, where distance of x and y, the y greater than equal to 0 for all x and y. And distance of x and y is equal to 0 only if x equals to y. Symmetry naman, where distance of x and y is equal to distance of y and x for all x and y. At the triangle inequality, where distance of x and z is less than or equal to distance of x and y plus the distance of y and x for all points x, y, and z.